Okay, we're going to get underway. Our first speaker is Jamie Burse, talking about Linux in Defence.
Hi, my name's Jamie. So, Linux in Defence, I just want to show what I've been working on the last 10 years, working on. So, introduction, I'll try to tell you what I like about doing it instead of reading all the background. So JAWN is what I work on, which is the Gingerlee Over the Horizon radar. Big high frequency radar system for detecting planes and ships and stuff to the north of Australia. So there's 3 radar sites out there, and in Adelaide there's a command and control centre and another site there for development of new stuff and more support activities. So it's all the Linux stuff we do and is all about supporting operations. So apart from all the development side, which is the fun part, the important part is your operations, which we have a KPI of a 98% uptime we've got to have. And like it says at the bottom, it's better to think of the radar operating as like a jet fighter. You know, there's no help desk at Mach 2 when you're flying along. And the radar's a bit like that. With their uptimes, they have about 40 minutes before it starts costing you money. You start getting fines from the government for having dropped the radar. And radars can run 24/7. You don't know, there's everything's planned, lots of planning, lots of booking, and yeah, your booking can get changed. So there's some more about operation support. So really what we're doing is supporting the maintainers. They're out at site, the techs. All right, there's no admins out there. They're just quite a few techs, in running shifts 24 hours. They're at Laverton, Longreach, Alice Springs, but they're usually outside of those places. That's the nearest, community you'll find. They're like mining towns out there. They're self-contained. They're really remote, so there's no one to call in. So we've got to provide these guys with the best tools they can get. Alright, so why do we choose Linux? Standard operating systems. It was open source. We have our own bespoke hardware as well for a lot of this stuff. A lot of the hardware for receiving and transmitting signals, so we want to be able to write our own drivers and not be having to deal with people VMS, which was early ones, or True64 Linux or Unix, I mean. So there was a lot of reasons, and cost and old hardware. We still have VMS VAX boxes out there, so there's a lot of old stuff, a lot of DEC alphas, and even some of the newer alphas, but there's just lots of old stuff. And we're trying to port everything over to Linux, but as we move a lot of it over, there's still stuff there we have to support. And to do all this, the best way to do it is engineering. Like I said, there's no one out there to admin anything or work out why that disk isn't, why things are failing, why the software's not working. All right, there's no one up. There's no software guys out at sites. And yeah, we still got to manage all this old hardware and stuff. So yeah, here we go, where it came from. Yeah, VAX, DEX, compacts, lots of HP and compact stuff, so we stayed with that. And we didn't know where some of those old operating systems were going, like VMS. Who was going to support it? It was meant to drop off, and then it kept support only. US Defence still have lots and lots of systems running VMS, but yeah, it's too hard. The TCP/IP stack is complete rubbish as well. So, so there we go. So we picked Linux. There were some crazy reasons for picking it at times. When you go back 10 plus years ago, people had heard about it, and it sounded good because at the time when you had Red Hat 7, it was it all looked free. So people thought that was a great idea. So yeah, we started with Red Hat 7.1, 32-bit, thinking that was the way to go. And yeah, it was because someone saw it on a magazine. Like, there was guys using Linux, but someone in DMO had also seen it, you know, some engineer on the DMO side had seen, oh look, we can get this Linux on a magazine. It comes on a CD there. Yeah, and of course all the Linuxy guys who were supporting Unix at the time were saying, there's even Windows guys saying, yes, this is good. It was amazing. So yeah, we developed we started on 7.1. By the time it went out onto the radar, it was end of life. So it was Red Hat 7.3 with all patches that were out at that time. Then we went on to RHEL 4.7, still 32-bit. We were looking at 64-bit. And just because True 64 and VMS were all 64-bit, so they were trying to match that up. Right? And we looked at lots of other hardware as well, but we're still using, you know, simple Intel hardware, HP stuff. And due to hardware changes, even in the Intel side, we've had to go to 4.8 on some things, so the CPU was supported. And then we had to update again to 5.6, RHEL 5.6, and that was just jumping from 4 to 5, just on the support side of, I think it was the teleuse licensing. They didn't support RHEL 4. So there's all these compiler issues you get that you're trying to support the guys having lots of fun. And so now at the moment, you've got 5.6 as your main operating system out there. 64-bit, and that's for all like your processor nodes and your workstations, and the servers, who are mainly file servers or just providing your services, are running 6.1. That was a bit of a quick rollout, very quick development on that, only because it was such a limited scope, being just the services and NFS sort of, you know, stuff. But we also have looked at now something like Scientific Linux or clones. I quickly ported all our sort of OS rollout software over a weekend at home. I quickly just incorporated Scientific Linux, which I could have put, you know, CentOS or, you know, any other clone of Red Hat in there as well. Just lots of case statements everywhere, and trying to find differences, any slight differences in between. And yeah, other reasons. The government is still trying to save money, you know, with defence cuts and that. They're always looking at that. And it's a funny thing that even though we got a really good deal on Red Hat licensing, it actually costs us more to work out if we need more licenses and to do all the back-end stuff than it is just to, you know, use a free one. It's actually, than the actual license cost itself, it's quite scary, some of these things. And yeah, like I said, now the Linux team's grown from me, one person 10 years ago, with now engineers sort of supporting and developing, because there's lots of different stuff. And so here's some scary numbers on engineering the whole lot. So yeah, the very first one, RHEL 7, took 4 years, or 3 years to get out there. And then it took 4 years for RHEL 4.7. It's other things in there, as engineering methodologies or procedures change, it can stumble you. It can drag you back by a month, because the engineers decided there's some new format of documentation or flow that they want to do. New tools, DAWs. If anyone's used DAWs, it's like a database for writing documents. It's sort of good and scary at the same time. And then transferring stuff over, that can be scary. An SDE came in, so using ClearCase, ClearQuest, all right, lots of stuff going in there. So yeah, so we keep adding, and that can be a problem too, is scope creep of your projects. Yeah, so basic hardwares and our install stuff. RHEL ISOs, tons more RPMs and tarbals that we use. And we structure a lot of stuff, lots of scripts, like 650 extra scripts on top of your RHEL install to build the whole network. And everything, all our builds are hands-off automated. So that goes back to the guys up at site. We want them to press a button. Pixie boot a box is like, that's the most we ever want them to do to boxes. Keep it as simple as possible. And that's the same thing with fault finding. Yeah, just basic HP gear is the bulk, apart from the Sun stuff on the SDE. And the workstations, the display guides that the radar operators use, they're pretty cool. Z400s at the moment with up to 4 24-inch screens, and some of the developers use 3 of them, like in vertical mode, which is really cool for developing code, I'll tell you. Yeah, so here we go, lots of engineering, even the configuration files to define networks down to a box, overall systems. You can see there's even a note there. It's not the perfect node naming because there's 2 primary contractors, and you always get, people deciding their way, they want it one way, and in the end you just have to make a compromise. So you can sort of see the odd one out in there, and where we should have moved the P. Yeah, and then apart from the node naming, we can now insert other things. So basic, well, it's a workstation, it's a processor, it's an operational node, development node. You can put them in higher up the list, but you've got to define it somewhere in your node naming list. So yeah, the node naming configuration hierarchy allows us to apply a change across the whole radar or down to a single box. Lots of scripts that we use. Yeah, so install scripts, installing programs, setup scripts, configuring DHCP or so even some of the compilers, anything, NFS, you name it. If there's a config file, we'll have some script for it. We generate all our Kickstart files all the time, so there's a script that does that. It will generate everything for your network, LAN, and yeah, even got set license files for different stuff for tele-use, and who knows, there's just lots. Unless you have to type it in. There's still some license stuff that you actually have to type in, the biggest key you've ever seen. Automated system builds, so yeah, the best one, primary servers. So we start with that with a USB key, and you can build the whole server off the USB key. And after that, you just PXE boot everything. So you build your servers, primary, secondaries, any more you got, and then you just start PXE booting the racks full of processor nodes and then workstations. So depending on your throughput of your network, you can just you get your whole site rebuilt very quickly. Server takes the longest, and workstation or any other processor node takes about 30 minutes to build it from scratch, which is good in a problem solving. The first thing, if you can't see the problem to fix it easily, you just rebuild the whole box. And there's so many of them, some of them have failovers, some of them you can just allocate another box to take over its position. So yeah, there we go. Simplified, so customized Kickstart that we generate, and you build a RHEL install, it reboots, it automatically kicks off a script that then does the rest of it, so that's another 15 minutes. So, and yeah, there's the big server one. Yeah. And yeah, the last bits that we always have to do, set passwords, about the only thing we can't do, and run confidence tests. So, because everything's engineered, you have a big checklist you have to run through, which might be turned out to be a scripted testing, and you can review that. There's our troubleshooting. Quick fix, reinstall a box. So we take the brick approach. Take a brick. If it's not working, who cares? You can just PXE boot the box, and it will get back to a known baseline. Everything is baselined. That's where it comes out the SDE, and you know that your server is set at the baseline. All the config scripts are set there. If you rebuild any box, it will be back to a configured and authorized baseline. So nothing gets out onto the radar that hasn't been approved by a heap of engineers and managers and the principal engineers. We have 2 contractors running these sites, so you have different engineering processes or different people looking at it too. Alright, so, and yeah, if it turns out to be if it's back there again after you've rebuilt it, which 99% of the time it isn't, then the techs might do some more investigation. They might pull the box out the rack. You always get hardware stuff as well, and then you can raise it as an engineering team down in Adelaide, and that's one of me and one of the other 6 guys, and we might investigate further. So what does the Linux SOA give us? It gives us a known base operating system. That's that baseline that we've got. We know that it's going to be the same, so it's the repeatability. Easy to expand a network. So when I started, we really had one network. There was only one radar we were playing with. Now there's 3. Once they came online, and they've gone over. So when we did those, it was a bit of a mirror. And it was even simpler for the other radars because they were brand new. They didn't have any of the legacy stuff that we had on the Linux side. So they went straight to RHEL 6.1 and 5.6 as their processing and workstation nodes. So they didn't have to worry about compatibility with RHEL 4 systems or even Red Hat 7.3 systems that we still got out there due to, again, legacy databases on Oracle databases that they have out there for gathering diagnostic data or whatever they want. Because someone hasn't ported it to the newer versions, it gets we get stuck there. And there's the important part is the ability for non-Linux admins or users or their maintainers to maintain all these systems up at site. There's heaps of people, all those maintainers, they're great. They've got guys up at site who could desolder your whole motherboard and put it back together if they think there's a hardware problem. But yeah, we haven't actually got guys up there who who are real Linux admins. They've had lots of experience up there with what they've got. They don't have time to, they've got to maintain their operating radar. They sometimes don't have a lot of time to play around on other boxes to get their Linux skills up, or they don't have a mirror environment like we do down at the development site to practice and play with some of the newer and harder things. So, questions, anyone? We're nearly out of time. 2 minutes. Oh. Yep.
Uptime seems a little low, actually, for a radar installation. I'd much prefer to have my plane being tracked 99.99 just ridiculously.
Yeah. Well, that's just a contract. I mean, it'd be up more. It's just that once we hit that, if you go below that 98, that's pretty much 40 minutes. So if you get a Cat 1 problem, so they can't use the radar or any three, whichever one they're using, they could be using all three at once. If they can't track that target for some reason, then they've got like pretty much 40 minutes to get it back online. They might be able to track it with, pardon?
So it's 98% tracked over a month?
Yes, yeah, so it might be, yes. So it's all contract talk, these guys, but yeah, they're 90% uptime, but yeah, there might be other penalties if they're down for more than 40 minutes on any one task. So they have different ways of measuring it, but yeah.
So, just before that question, if we can start getting set up for the next presentation and then take a couple of questions while that's going on.
All right.
So, Kevin?
You mentioned that you didn't get anything satisfactory out of the support. Was that any expansion on the question of the support not being satisfactory for you? You said on those slides, three support calls, no satisfactory outcomes.
Yeah, we haven't had many. One was turned out to be an NVIDIA graphic. It was for the video cards, so we've had them, and we get a thing sometimes, or even a tape drive, LTO tape drive recently, and we put in a call to Red Hat, and they say, oh, it's a HP hardware, it's HP's problem, and HP go, no, it's Red Hat's problem. So you get that, people going against each other. And same with the NVIDIA. We went to Red Hat, they said it's NVIDIA, so HP actually helped us talk to NVIDIA. We got lots of NVIDIA cards with the multi-heads. And that was going from some of the older cards, which are, they've got really old special cards, that all these hardware extraction layers, so it's just, some of the software is written strangely, so lots of layers, having like 500 layers lined up at once. It's weird how they do it. Any more questions? Oh, yep.
Not really a question, just to share. I work for Mozilla IT. We've got this pretty much the same setup. A lot of BL 460, so we interact a lot with HP and Red Hat.
Yep.
And primarily, probably in the last couple of years, our experience has been pretty much the same, except recently we've started interfacing more with Red Hat, and they've been helping out much more. Like, we had issues with Broadcom chips on the network cards that machines would just reboot or crash. Yep. And Red Hat actually patched it pretty nicely, so kudos to that. They've been helping out. We've had the exact same thing, HP, Red Hat, Red Hat, HP. They point fingers at each other, so
yeah,
it's good to know that they're working on that.
Yeah, we've got, with our environment too, as you see, there's no, it's a set baseline. You can't upgrade, it's really hard to put patches in. Unless it was a really critical error that we really needed to fix, we wouldn't even patch stuff at times. You know, upgrading internals, we'd just make a whole jump. They might, you know, jump a whole box from RHEL 4 to RHEL 6 or something, or RHEL 5. It can be really hard. We can do it, but of course there's all this engineering side that we'd have to, you know, re-verify software, which can be really expensive. It used to cost lots to re-verify how the radar runs and the software, so it's just, yeah, the engineering side of things really slows you down at times, but good fun, yeah.
Just wanted to mention that there is an alliance between major vendors like IBM, Red Hat, Microsoft, with a package. So if you raise a support case with one of them, and you just raise with HP, you will never have to interact in both of those cases again. You just need to mention basically to Red Hat the number of HP keys. So that's what they asked me, for example, to do. And that's it. So from there on, you will interact just with one of them. It might be HP, it might be Red Hat, it might be Novell, whatever it is, but just one of them.
Yep.
Okay. And right, we really need to wrap up now. Thank you very much, Jamie.
Yep.